I'm a PhD student here at the University of Southern Denmark at the Maersk Institute. In this presentation I will show you a little bit about how to analyze your software, your monolithic software, while you are porting it to the NetBeans platform, while you are modularizing it. And this will be work of mine and my advisor both. And some of this work is also based on previous achievements of Kemal. So the tool that I will present here is a tool for the NetBeans IDE, or also the NetBeans platform, called Featureous. So the motivation scenario that we have here is, as Hertian previously introduced, is a migration of monolithic application to the NetBeans RCP. What happens then is that you want to modularize your features, and this is because the features become your units of deployment. So it means that you add something new to your application, then you would like to add a new feature, and then you would like to deploy a new feature. The same happens when you, for example, get a change request. Then a user says, oh, maybe I'm not completely happy with how you do, I don't know, code completion in the source code, or something like that. Then it's a change request that is dealing with a specific feature. Then you would actually like to focus only on this feature in your source code and look only on that, on nothing else. And then when you know about that, then you would also like to divide the work among the programmers in your team according to features. You would not like to divide the work according to layers, for example, GUI, controller, models. So a more detailed example will come here. I named this slide the secret life of monolithic features, because there is actually something quite secret about it. But before I talk about that, I will tell you what I understand by a word feature. By a feature, I understand a bundle of user-identifiable functionality. So, for example, as I wrote here, it's, for example, create a new project. This is a feature. Or a project management, where you create any project, you can close it again. That's a feature. For example, if you have a traditional software system that models how university works, then you can have a feature which is enroll a student, because it provides you some functionality, allows you to do something with the program. Yeah, why the life of features is secret in monolithic applications is because features tend to cross-cut architectural units. So I assume that many of you know this kind of traditional way of arranging your architecture around model, view, controller, around those three layers, where layer above can depend on the layer below, but it's like the other way around, it's not really permitted. And what happens when you have a feature, for example, this example with enroll student, what will usually happen is that you have some GUI for it, right? For this feature, because a user needs to maybe input a name of the student and press a button, say, do it now, enroll a student. Then you have some GUI for it. Then the control flow of your program will go to controller layer, because there is some domain-specific logic. You have to check if the student is already registered, or maybe if he has the appropriate age to go to the university, or whatever you need to check there. Then you go down to the model layer. Then you actually have to do the stuff. Then you have to say, when we zoom in on this diagram, you would have to say something like, maybe university, enroll a student, then you create an instance of a student, you give it as a parameter, then add it to some kind of collection, then maybe already subscribe him to some courses. So you can see it's like, it just bounces around this feature here, not only between layers, but also between classes in different layers. Also between methods and inside of the methods. And when this happens, then your control flow will just return to the controller layer, then it will return to the GUI layer to display some kind of confirmation, some kind of output of your action. So for example, in this case, it was successful, so the student was enrolled to the university. So, what is wrong about this picture? Yeah, you could say there is nothing wrong about it. Yeah, I would say this can be actually a good answer, but it depends. It depends on what kind of evolution your software will go through. If during your evolution you will substitute your view layers often because you, for example, would like to support different kinds of GUIs for different platforms. And that's very fine because you have your view as a separate layer that you can just throw away and build another one on top of the controller. But if you will extend or modify your application according to features that it has, then it's kind of complicated because then whenever you have to modify something with the enrolled student feature, then you will have to, and maybe you want to fix a bug, then you will actually have to go and look in all those places searching for where the problem is. And this thing that you have to go around and visit different places in the implementation of features is called scattering. So, implementation of features is scattered over different units of your program. Then there's another thing. Features can be tangled with each other. So, if you look at those classes here, student, course, university, they are not really features specific to enrolled students. There can be other features that use the same classes, like, for example, assign a teacher to a student or something like that. And then they would be tangled in terms of those classes. Then, when you want to split the features and have them evolving independently, then it will be difficult because a change made in a shared class for one feature can also propagate to other feature and potentially break it. Next problem about this picture, according to the feature perspective, is that the boundaries of features in the code are implicit. So the problem is that here I draw this line, so we can see where the feature goes, but it's not so obvious when you have a big program that you don't know beforehand. And there's also implicit dependencies between features. So basically, it can happen that you have your requirement specification where you specify how features depend on each other, how the logical dependencies go, but in the source code it can be very different. There can be other dependencies. So the overview of the tool that I will show is that it's called Featureous, and it has two main things. It allows you to locate features in unfamiliar code and analyze how they are implemented. The location part is done by just preparing a program. I will show you how to do that in a moment. Running it, we have implemented an AsciiQ tracer tool that traces the execution of the program, and it produces the feature traces that basically show which parts of the program participate in which features. Then, based on that, you can have multiple views, like, for example, here source code view, or some kind of correspondence graph between features and classes, or some kind of other charts to analyze the features to help you better understand how they are implemented in your source code and how difficult it will be, or where are the hotspots when modularizing your application. So, and the perspective for the future, I will just briefly mention them, is that it is our goal for the future to look into how to support the modularization step itself in the future. Right now we support the analysis step. So the rest you have to decide about yourself. But we are looking at ways how to help programmers do that. We'll have a website coming soon at this address, featureous.org. Then you will be able to see some things down there and download the tool. The demo, I will show you how to analyze the features of this mind mapping application called FreeMind. And I will just take a very early version of it because it's very simple, so it will not be overly complex to show it to you for the purpose of this demo. And it has, in this version that I will analyze, it has 13 features. Okay, let's do that. So as you can see, I'm running Windows in a box on Mac. Yeah, but I have good reasons to do that, but we can talk about that later. Okay, so this is basically the source code of the. You can see that. Okay, this is basically the source code of the tool. So there are some couple of modules down there. The main module that when you would like to, it's actually possible to create custom views on top of the tool that we have implemented. If you just import this core module, if you create a dependency on it, then you will be actually able to plug into our infrastructure and create your own views on top of what we have done. So, okay, so I have already executed the tool. So this is the NetBeans platform. The first things that you can see here is two new buttons down here. One of them is called Trace Project. which is basically a modification of the standard run main project button. This will basically